Example 3 for the sum and difference or product of functions. We're asked to sketch the graph of y equals f minus g of x, where f of x is x squared and g of x is the square root of x, and both of those are defined under different domains. The first step when we do this is to write the new function. So we're going to do f minus g. We are asked to write a function, which means that we do need to have a domain in that. So it's going to be y is equal to x squared minus root x, but it's only defined where they both exist, which is the 0 to 2, i.e. g. Now when we graph this, we're going to sketch the original graphs. I'm going to sketch x squared in pink, and I'm only going to sketch it within the domain of 0 to 3. Sketching g of x, which is the square root, in green. And again, I'm only going to actually graph this between 0 and 2. Note that the purple graph, which I'm about to put in now, is the x squared minus root x. And the points that I'm going to get here, so this point here is 0 minus 0, so 0. I've got my two functions meeting each other, so they're both at 1 at the same time. So 1 minus 1 is 0. If I go my pink graph minus my green graph, I'm this distance below my pink graph is where my new difference function is. Here, pink minus green is below the x-axis because I have a small positive minus a larger positive to give a negative. This forms my equation, or my graph, I apologize. So graphing that in is what I get. And just noticing some key points, like where I hit my green graph here is the same distance as it is from the pink graph. So pink minus green is this same distance in here. Alright, this didn't actually ask us to do it, but I'm going to anyway. Just graphing it using my CAS calculator. What you're going to notice is that I've only graphed within the domain of 0 to 2, so I haven't graphed the whole thing. So what we've got there is that little portion of our difference graph. I'll zoom in so you can have a better look. I can also graph each of my separate functions, so x squared and root x. So if I put in x squared and then root x, there are some key points to look out for. So for instance, we have a key point here at 0, this here. So our new function and our old function when x equals 0, we've plotted that point in there. When x equals 1, I apologize. And then this part here, so same distance here as it is here. So we've successfully graphed our portion of it, and you can see some key points. Now, it's looking for these key points that will help you with the graphing of these sort of functions.